The topic of today, Milankovitch cycles. Let's split these words, Milankovitch and cycles. Milutin Milankovitch was a Serbian engineer and geophysicist. His life's work was to formulate a mathematical theory about the variations in the Earth's orbit around the Sun. And then, cycles. A cycle is a group of events that happen in a particular order and are often repeated. In nature, many cycles can be found. Think about seasons and sleep patterns. If we now put the words together, we get Milankovitch cycles. These are cyclical orbital movements, so changes in the Earth's position relative to the Sun. These changes cause a variation of a maximum of 25% in the incoming solar radiation at Earth's mid-latitudes. Together, the three Milankovitch cycles are strong contributors to Earth's long-term climate and determine the start and end of the ice ages. So, the fact that the Earth currently has a climate suitable for all current life is partly due to these cycles. The Milankovitch cycles are determined by variations in three types of parameters. When speaking of the Earth, it is important to know that her orbit is elliptical. An ellipse has the form of a closed oval that is symmetrically shaped. It has 2 points that act as the center of the oval. Those points are called flotchi. The eccentricity of an ellipse refers to how flattened or round the shape of the ellipse is. Johannes Kepler concluded in his first law that the orbits of most planets are ellipses, with the Sun as one of the two flotchi. The other flotchi is the gravitational pull from the two largest planets of our solar system, Jupiter and Saturn. The flattening is expressed as an elliptical value that varies between 0 and 1. The more flattened the orbit, the closer the value is to 1. When the value is 0, the orbit is perfectly circular. Earth's orbit has a value of 0.0167. Eccentricity is the reason why the seasons have different lengths. In the northern hemisphere, the summers are approximately 4.5 days longer than winters, and springs around 3 days longer than autumns. When the eccentricity decreases, the differences will decrease as well. Earth's axis of rotations are tilted. The angle of this tilt is known as obliquity. For the last million years, the tilt of the Earth varied between 22.1 and 24.5 degrees. Currently, the Earth has a tilt of 23.4 degrees. Obliquity is why there are seasons on Earth. The greater the axial tilt, the more extreme the seasons will be. When one of the hemispheres is tilted towards the Sun, it will receive more solar radiation during.
Created using Powtoon.